All right, welcome to the January 2025 Cincinnati Ruby Brigade meeting. This month, we are going to have Chris Nelson talk to us about Ruby and the convergence with WebAssembly, but WebAssembly and Ruby, and a little bit of Rails.
All right. Okay, I'm sharing my screen. So everybody here knows a little bit already, probably, although I don't know. I'll give a little bit more context. Ula, I don't know how much WebAssembly you've gotten into, but I'll just sort of so I don't have any slides prepared in particular, and I only got as far as like a topic list of what I want to cover in my head. So I would love to have people ask questions if what I'm explaining and talking about doesn't make sense. But WebAssembly, I assume probably people know in general what WebAssembly is about. But it's been around now for a pretty long time. I think I said 2017. And at its core, it's a virtual machine and instruction format. So in that way, if you think about virtual machines, obviously like Java comes to mind, and it's got a lot of kind of similarity to Java. I guess the main difference is WebAssembly went through a standards process and has been adopted and implemented by all the browsers. And when it started it originally, its goal was to give an option for executing code faster in the browser was the main goal. But as it became standardized, people saw like other uses for it. WebAssembly, like the original version of WebAssembly, is like fairly low level and limited in terms of what it can do. WebAssembly, you can really think about it as like a compilation target. It's like an imaginary computer and an imaginary binary instruction format. And what it can do as far as like in its original version, when you compile code to WebAssembly and then you talk to it from the browser, how you can invoke WebAssembly code in terms of like what you can pass it and how you can interact with it is really pretty limited. WebAssembly maintains its own patch of memory, and you can pass numbers in and get numbers back from WebAssembly code. So that's not really very much. And you can also like on both sides. So if you're executing WebAssembly code from the browser, you can interact, you can allocate memory for WebAssembly and like interact with that memory yourself. So, if if you're doing certain things, that's like enough. Like people have built amazing things with like original core WebAssembly. And if you're doing like computation stuff, that might be good enough to do what you want to do. And that's what a lot of like the early big WebAssembly things have mainly been about. Like if you're mostly doing graphic stuff, yeah, you're working with numbers and you want it to be really fast. And WebAssembly as it currently existed was good enough for that. But if you think about like doing something as simple as writing hello world, you can't actually easily do that with like originally WebAssembly because there's no good way to work with strings. There's no, you just have a patch of memory, but there's nothing in the original WebAssembly spec about like string encoding or what lives in that memory. It's just like the Wild West. and both the environment that's hosting, executing a WebAssembly module, and the code that is compiled into WebAssembly, both those sides of the equation have to agree on what am I putting into memory and what does it mean. And like as a programmer that's, you know, like certainly as Rubyists or working with most high level languages, like that level of detail is not something that we're used to having to deal with. And it's really, really tedious. So like if you want to write a hello world program, you're talking about like, hey, I'm going to put a string in ASCII format at this address and it's this many bytes long. And so I can tell, you know, I can pass in numbers that are like the length and the offset into the WebAssembly code, and then the WebAssembly code can read the memory, and then maybe it can put something else in memory at a different address, and it can tell the host program, hey, here's this memory, and you do something here. So it's like really tedious, and it's like not practical for like most application development. What got me excited about WebAssembly again, and most, you know, a lot of people in this room have already heard me talk about it, is something called the WebAssembly component model. And that's not the link that I wanted to go to now. Oh man, bear with me. The Zoom control panel is like right in the way and I can't get to the browser tabs that I want. Oh yeah, the WebAssembly component model. It basically is a layer over top of WebAssembly, the core WebAssembly that like addresses some of these issues. And the main the main issue that it solves is how do I interact with WebAssembly with high level types that I'm used to, like strings and lists and records and all kinds of things. So it defines like if I'm putting something in memory, you know, how is that supposed to be laid out? What goes in that memory? And basically like a way to marshal and unmarshal high level types into and out of this memory. So that like if when we talk about WebAssembly, the words that commonly get used are hosts and guests. And so a host environment is something like a browser, and there are other ones now that is executing some WebAssembly code. And then the guest environment is the code that is being compiled into WebAssembly. So the host and the guests can now, with something like the component model, they can be different languages, but still interact with, you know, high level types like you're used to. Before I get into the component model, though, I'm gonna try to back up a little bit, and please, like help me stay on track as best I can. So with Ruby, the story with Ruby and WebAssembly. So with any language in WebAssembly, they're like two different things that you might want to do. You might want to take your language, you might want to write code in your language and compile it into WebAssembly. And you also might want to, from your language's code, be able to execute code that's been built in WebAssembly. So those are like two different problems, and I'm gonna like look at both of them. But in general, hopefully that makes sense. The cool thing with Ruby is not all languages have as good a story for like compiling into WebAssembly, but Ruby's like actually done pretty well. The Ruby interpreter itself, because it's written in C originally, and C is a language that has had compilers to WebAssembly for a really long time. There's a project that I'm going to bring up the webpage for when I found it. Ruby.wasm. So the other thing I should throw out there, I haven't done a lot of Ruby in a really long time. So my knowledge of Ruby is kind of out of date. Uh, but at this point, like the way I understand it, ruby.wasm is kind of like the landing page to talk about the landing place that kind of describes all um, the different ways, I guess, to compile Ruby into WASM. But I think at this point, it's like kind of part of standard Ruby itself to be able to compile Ruby code into WebAssembly. And what I was able to find is like a pretty good example project of here's how to just execute Ruby inside of a web browser. So um, somebody's, the Ruby core team has made it possible to compile the Ruby interpreter into WebAssembly, and then you can just like execute the Ruby interpreter from your web browser and run Ruby right in your browser. And they've also done a really good job of like taking a bunch of stuff from JavaScript and making it interface with the Ruby code. So you can actually like, I was really kind of blown away with like how much you could do and how easy it was to work with. So um, I just, like half an hour ago, downloaded and built. I don't know if I have the tab. Yeah, I downloaded the demo project, which compiles a whole environment into WebAssembly for running and interacting with Ruby code in the browser, and was just kind of playing with some of the demos that they have. So the demo that I got running is this, well, the first one, I think they all probably run, is just like a little, of course, a to-do list. But I'll show you the code. It's all like Ruby. There's no, the JavaScript is basically just like a thin, well, there's no JavaScript code at all, but it's interacting with the JavaScript environment from like an integration layer from Ruby to JavaScript that I'll show you with. So I just did one thing to prove that I could, which is like I click button. If you click the button, it's going to like stick on some extra text. And I just did that to prove that like, yeah, it's actually recompiling the Ruby code and that, or reevaluating because it's an interpreted language, the Ruby code, and everything's actually working for real. That's not the right editor, but this one is. So, and this is the actual code that we're looking at here. So with this example, let's maybe see where it loads the Ruby interpreter up at the top. So yeah, the Ruby WASM project has built this guy over here that loads the Ruby environment and then lets you execute Ruby code within script tags. So this .js file loads the Ruby interpreter WebAssembly module and like fires everything up. And then what that lets you do is in your HTML, you can just have a plain old script tag with type equals text Ruby. I assume data eval async. I assume it would do something different if I made it sync. I don't know what. I haven't gotten that far. But then at that point, it's Ruby code. And this JS has a bunch of things that you might need to interact with. This is like pretty self-explanatory, it seemed to me. I haven't dug into like the JS API at all, but it seemed really straightforward. What this guy is doing is putting all those to-do list items in local storage. So if you like reload the page, everything's still there. And this is where it like updates local storage, but you can do things like grab the LI items and then like each over them. You can do things like add event listeners and just give them blocks of Ruby code. So it's like, you know, the event listeners and Ruby blocks, all that stuff is all, it works the way you'd expect, which is like the cool thing about Ruby is mostly, you know, the way the Ruby community just makes things intuitive is really awesome.
So real quick question. Sorry, try to say that three times fast. That's actually Ruby. Those are actually Ruby methods that mimic the JavaScript, I guess, like label dot add event listener or click on line 106.
Yeah, that's Ruby code, but interacting with a JavaScript DOM element. And
Yeah,
yeah,
Camel case.
that's really blurring the lines
it is.
between
Yeah,
the
the camel
languages.
case is weird, right?
Yeah,
My guess is
yeah.
like, my guess is like they just like
Yeah.
shim the stuff directly and haven't, you know,
Right.
bothered converting anything to snake case.
Yeah, I don't know if it's worth it or not. It looks familiar as camel case, but weird in the context of Ruby.
Right.
Yeah, yeah.
Yeah. But
That's
like,
fascinating.
yeah. So here's where I made my little tiny code changes just so that I could. Like it's a button to add event listener, and then I call add item, and I just like this is just getting the inputs value and packing on some extra stuff. And this is like that's what happens when you submit on enter. So I could do something, you know, like I can't type, I guess. And then I don't even know if I have to reload the page. I don't know if it's doing hot reload, so let's just do it ourselves. Come on. Maybe. Yeah. So it's definitely, you know, on page load, it's evaluating that Ruby code. Interesting things to point out, maybe, just because I was curious. So that Ruby app.wasm, that's like that's the WebAssembly module that contains the Ruby app, which I assume is the interpreter and all the gems. Or I don't even know. I haven't like really dug into that. But that thing's 35 megs, so not tiny, you know, as you might expect. Honestly, 35 megs, I thought it might be bigger than that. And, you know, that may or may not be tolerable depending on what you're doing. I would also think like if that's the interpreter, that's very cacheable. Like for your app, you know, you don't have to load that every page. Like all you have to do is like evaluate the Ruby code on that page, which the Ruby code, you know, all of that, that's really small and it executed really fast. Obviously everything's local, but I think I ran the first version of this demo over the network and it was perfectly reasonable. So I thought this was really, really cool. Like it made me think like, wow, I wonder what, you know, is this actually viable? Like what could you do with this? This seems pretty great for me. I was kind of surprised that I haven't heard more about it. I've paid attention to Ruby and WebAssembly off and on for a couple of years, but I hadn't really tried to get anything working, and to see that they'd really gotten to this level was pretty impressive. There also, I didn't get far enough to try to run the demo here, but if you look for Evil Martians, WASM, Ruby, Rails, my guess is you can find, yeah. So what they've done is they actually took Ruby, a full Ruby on Rails app, and actually got it to run inside of a web browser. And I think they did that by, I'm thinking, if I'm remembering correctly, they took SQLite, I think, and just you can compile that into WebAssembly, so you have like a database engine inside the browser as well. At this point, you can actually compile Postgres to WebAssembly and run that side inside the browser, which is ridiculous. But it's like a whole app, you know, server as well running inside the browser. Like
Active record and everything.
yeah,
Yeah.
all the things.
Uh-huh.
And they got it to work. Like, why? You know, is it practical for anything? No, probably not, but it's super interesting. And so, like, I think, yeah, Ruby's story for compiling into WebAssembly and doing stuff is pretty far along and pretty interesting. So I thought that was pretty cool. Okay, well, that's like halfway through. This is the perfect time to segue. So the other side of the story is Ruby code being able to interact with or being able to host WebAssembly code. And for me, that's where the component model really becomes really kind of critical. Originally, you know, the WebAssembly, you know, browsers were the original WebAssembly runtimes, but over time, people saw that, like, okay, having a standard compilation target for a code is pretty useful for a lot of things. And so WebAssembly environments outside of the browser, like server-side WebAssembly, has become more and more of a thing in recent years. And one of the things with server-side WebAssembly is you need kind of a way to interact with the outside world, like when you're not in a browser, like being able to read from files and interact with the operating system and make network calls, doing all of that. Like, there's nothing in core WebAssembly to standardize that at all. So what happened to be able to allow that stuff to happen is there was another standard that evolved called WASI, or the WebAssembly System Interface. And the first version of that kind of mimicked POSIX, which is like low, and I'm not an expert here, so I'm like a little bit out of my depth, but the way I understand it, it's like a low level interface for like languages like C to talk to an operating system like Unix. So WASI is fairly low level and clunky, and probably only like something, I'm sorry, WASI version 1, I should say, is fairly low level and probably like familiar and great if you're a C programmer, and maybe less so if you're programming in something else. But WASI, that same organization that standardized WASI, they are the folks that came up with a component model because they realized like that version of WASI was too clunky to deal with. And so the component model that brings, like I said, high level types to WebAssembly. And the way the component model works is you have something called WIT, which is an interface definition language. And it lets you specify basically the type information that you need, like the typed description of what's in a WebAssembly component, which really is the same as a WebAssembly. It's a layer over top of a standard WebAssembly module. I realize I probably haven't defined enough terms, so please, ask questions if what I'm saying doesn't make sense. But the interesting bit for me is it gives you like a language agnostic type system. So it has built-in types and it has user-defined types. The primitive types are like kind of what you would guess, Booleans, all of the different kinds of unsigned and signed integers of different sizes, floats, characters, and strings. And then lists of those types option. So the wit does not allow nulls, which I think is an interesting and good decision, but might require some adaptation to your language. So it has option types. It also has results, which your language may or may not have. It has tuples. And then it has user-defined types like records and variants and enums. It also has something that I haven't dealt with yet, which are resources, which are like handles to stateful things outside of a component. And I haven't dealt with them enough to really be able to say much about them, but you definitely, they're definitely things that you might be very useful and necessary as you build a more interesting system out of WebAssembly components. What got me interested in WebAssembly components is I'm really interested in the idea of using this to build systems where the user wants to extend the way that it works. And if you think about it now, the way that usually works is like, okay, if you're working like a SaaS platform, even like GitHub, and you want to do something like, I would like to, have something happen and make an entry in a spreadsheet anytime somebody commits. Well, you set up a webhook and then you listen to that webhook and do whatever you want. But really what would be awesome is if you could provide GitHub some code in a safe way that didn't, require you to adopt a certain language and basically say like, here, GitHub, here's some code that I want you to execute on every commit. And I'm interested in the WebAssembly component model as like a way to be able to do things like that. Yeah, I do feel like I'm wandering around a little bit all over the place, but let's look at wasmtime-rb next. And wasmtime-rb is the server-side WebAssembly. It's a server-side WebAssembly runtime that will let you host WebAssembly code and execute and interact with it from Ruby. And in the I don't think it's in the released version of it yet, but in main, they have committed at this point support for the WebAssembly component model. So it's really, really early on. And so there's a lot that it can't do yet. And I would say it's not really useful quite yet. But let's see if I can find the, I don't even know. Do I have the component types? I'm looking for like the WIT world that describes, and I don't know if I have it here. Man, I thought I did. So what I'm looking for is the description of the WebAssembly component that they use for all their tests. And I'm not, I wonder, is it here in examples? So I have the WebAssembly module and I can load it and execute it, but I don't know if I have. I don't know if I have. So I have it somewhere else. So I am working on the Elixir kind of version of wasmtime called wasmx. And so I think I have that file that I was looking for over here. Really? That's why I couldn't find it. It's probably on both sides. Oh, doesn't matter. So this is like a WIT file that's basically like trying to exercise all of the conversions from your language into and out of WebAssembly components. So it's just defining a bunch of things, you know, it has a record and a variant and an enum and all of these kinds of, so it's basically like a bunch of functions that are like identity functions just to test that, hey, you can pass a thing in and get it back out and it'll do the type conversion in and out. And that's kind of about where the WebAssembly version is. And I can do it again, but like I was just now getting to the point where like I can load a WebAssembly component instance and I can call functions that take a complex type like a record and are able to send it in and get it back out. So obviously like that's cool, but like what you really want to be able to do is have your WebAssembly code probably interact with the rest of the outside world. And over in Ruby, I haven't quite figured out how to do things like that yet. I should be able to like from my WebAssembly code, I should be able to like make network calls and interact with the file system and do things like that. And I think they're still working on that from wasmtime-rb. I do have some of that working, or really all of that working over on the Elixir side. So my guess is like it shouldn't be too hard for them to get there. But at that point, it'll be viable to do things like, okay, let's say I'm Shopify. I could like define a interface in WIT to say like, here's how you provide me, you know, your discount calculation logic. And you could write your code in, you know, whatever language you want. Well, I guess it's whatever, any language that can compile the WebAssembly components. You can, you know, write that code and then upload it to Shopify, and that would like be the discount logic for your instance of Shopify. Those are the kind of things that I'd like to be able to do, and I think we're pretty close. Yeah, I think I might be. There's a lot to this topic, so I'm just gonna like pause there. What would people like to hear more about, if anything?
Tell us like what you can you tell us a little bit about the Elixir side, what you've been working on, like what you're working on now, and what the main goal is?
Sure. Turn off the cameras and let's fire up the Elixir meetup. No, I'm just kidding. So on the Elixir side, let's take.
Are you saying the Elixir side is what you guys are doing is farther along than what's been done in Ruby at this point?
Yeah. Let me show you like, so on the Elixir side, like this is one example. This is like a really simple example of calling into like the outside world from within a WebAssembly component. So I have a very tiny WIT world with a function called getTime that returns a string. So nothing too exciting there. But the way I'm implementing that is I'm writing some JavaScript code that then does a fetch out to an external API, takes that JSON back, and then like returns the result of it. And I can, well, actually that should just be, should have a test case for that. WASI test, yeah. So this is what it looks like to actually execute that code from Elixir. I load up my WASI module. I start a process to manage that WebAssembly component. I give it some options to say, hey, you're allowed to talk to standard out and you're allowed to make HTTP calls. And then I can just interact and invoke that function and get the result. And that guy should just work. Looks like it's going to have to compile some Rust code. Other interesting things about WebAssembly, if you do much WebAssembly, you're almost certainly going to end up writing some Rust code fairly soon. Like wasmtime-rb and wasmx both have substantial chunks of Rust code. But yeah, this is like the response I got back from that API. And,
so the component that was compiled into WebAssembly was the JavaScript
yep.
piece? Okay, got you. And so you compile that in there and then you're calling that.
Yeah. And I could make code changes to that and like build it again. And we could say like, so just for fun, go into, where's that test? Fixtures. So I need to like build that JavaScript WebAssembly component again. But then once I do that, we can go run that test again. And crash it. What did I do?
Okay.
Oh, that's an object.
Oh.
Yeah, let's just do it this way. That'll be better. So I tried to like plus an object, and that's completely ridiculous, invalid JavaScript code. You can't do that.
Oh yeah, it was returning the string.
Yeah.
I got you.
Okay, so that time it took too long. And this is a thing that can happen because I didn't turn the timeout high enough. I wonder. I'm just going to like avoid that for a second because it's annoying me and I don't know what's happening.
Can have a response.
Oh, yeah, that won't work either. It's just getting silly, but
Must see my name up there. Oh, there it says, "Hey Joe." See it?
oh, where? I lost.
Well, it says test outbound HTTP call. Hey Joel. And then.
Oh yeah, there it is.
Yeah.
Yep. That's where the console log shows up.
And then the test fails because it doesn't.
And then the test fails because it's returning foo instead of what it said.
Yeah. Cool.
Yeah. So yes, if the network call takes too long, or it's the combination probably of like loading the module, which is kind of slow. So JavaScript also being a interpreted environment, like that WebAssembly component also has to like basically bundle in a JavaScript interpreter. So it's much larger and slower to load than if you built it in Rust, where it doesn't need any interpreter at all, and it's just tiny. However, the good news is like with these WebAssembly components, especially with Elixir, you can start up a process that basically has done all the work to load that WebAssembly component. And once it's loaded, and whatever it does to warm that thing up, I don't even know. But once it's loaded, calling functions on it is really fast, like milliseconds. So what you would do in an environment where you're trying to like take this approach to production is you basically like you'd spin up a pool of the WebAssembly modules, that you needed to have around to be able to execute at runtime and just keep them warm. Obviously, you'd have to do that for everybody that was like defining some custom logic in a WebAssembly component. But what they're doing is they're comparing this to something like Kubernetes for serverless, where it's like, oh, you need a whole like Docker container to be able to do something like this. So these things are obviously much smaller than that. So yeah. I guess the other thing that I can do that, let's see. Oh yeah. So the other thing to point out that is really interesting is like this whole thing I only showed you so far, exporting functions from WebAssembly components that I can call as the host. But the other thing with the WebAssembly components is you can also define imports, which are things that your WebAssembly component wants to be able to interact, to call itself. It's bidirectional. So I can define basically callbacks in Elixir that the WebAssembly component code can call. And imports are the way that you do that. So you're basically saying like, this WebAssembly component, here are some functions that it can execute if it needs to. And I have that working on the Elixir side. And I think doing that, I don't know where they are at with Ruby on being able to do that, but that would take some level of effort. But on the Elixir side, there's already some work to be able to do that in core WebAssembly that I was able to leverage. And essentially, it's like asynchronous under the covers, but it basically under the covers, it's all just like processes passing messages back and forth. So like my WebAssembly component, I'm defining the import in some Rust code that then ends up sending a message to an Elixir process and getting one back with the result. But I can actually show that. So like what I'm doing over here is I'm basically like in the JavaScript code, I import these functions as if they're JavaScript modules, and that just works. And then I can like call them over here. And yeah, I'm not doing anything interesting yet. I'm just proving that like I can export functions that use these other functions that I define over in Elixir. And then in the test, this is what it looks like in the Elixir code to like set up the imports. I basically just map their names onto Elixir functions. And I think do I have an example of like, kind of like making this nicer in Elixir? Oh yeah, so where I'm trying to go eventually is like, I want components to basically just become Elixir modules. And so this is kind of like the macro syntax for doing this. And I basically like load up the width, and that will give me it will basically define functions within this hello world module. And let me do, yeah, it will let me do things. Yeah, here's where I'm trying to go eventually. It will let me do things like, okay, I want to load up my component, but then I can call, it's basically making those with functions into underscore standard Elixir functions that I can call and give it like standard Elixir arguments. I just pass it the PID, which is the process identifier of the component, to interact with it. So it's like more idiomatic Elixir.
Mm-hmm.
So
in your Shopify example, I would be writing that JavaScript component and submitting it up. That would be getting compiled into their WebAssembly. And then their server code, if that was in Elixir, that would be calling into like, and it could, I could be writing that in Ruby or JavaScript or whatever I wanted to.
yeah,
But anything that's
or Python, or
anything
whatever.
that's supported by WebAssembly or has that translation. And then, and so Shopify on their server could just execute any code, that I had submitted.
Yeah,
that's cool.
And it can do so in a sandbox where it can like apply whatever limitations it wants. You can't talk to any files. You can only make network calls to this address, or maybe you can't make any network calls at all, because Shopify could then define like, here's a bunch of functions you can import if you want to like do something in Shopify.
Yeah.
But you can't interact with the outside world at all because security.
Yeah.
Yeah, that's sort of the way I see it shaking out.
Do you? Because I mean, gosh, that has nothing to do with the web, right? It's just.
Oh no, yeah. No, this is like we forgot about the browser. I don't know what they're doing over there.
Yeah, and
I don't care. I'm just a server side guy.
I mean, it's interesting because it seems like what's the first part is like, well, you're gonna be able to write any like script, browser script code in any language you want, not
which
just
is cool.
JavaScript.
Yeah.
And do you think that that's a novelty, or people like really, is that's going to happen kind of?
I don't see why not. I honestly, I hadn't looked in on where that was at until like a couple hours ago.
Okay.
And I was like, wow, this is really cool. You can actually like write Ruby code that does stuff, and it seems to work and be really, it's actual just Ruby code, right?
Yeah.
And so I guess I'm surprised there aren't more people talking about it and doing it. But I don't know why or why not.
Yeah.
I mean, obviously, like that interpreter being 35 megs is a thing.
Right.
So I could see that like not being viable for certain kinds of apps, but I don't know where people are at with that.
Yeah.
But like I said, I'd been more the thing that I was really pushing hard on was the server side thing, because I see that as a much more like, it's a way better solution to what we solve now with this like contraption of like webhooks and API calls back and forth. Maybe, I don't know.
It's crazy that like this is just happening now in a way.
I mean, this is like the promise of Java, but Java was not standardized in any way that like, and there was also like, even with Java, there was never like a standard type system and mapping to, to memory. Time to wrap it up. Okay. Wrapping it up. Hit the wrap it up button.
Thank you, Chris. That was awesome. Appreciate you throwing that together for us and giving us a look.